Hi there, in this video I'm going to explain how to work out the determinant of a 3x3 matrix. So let me title this Determinant of a 3x3 matrix. So take a red pen and a ruler and underline this. So if you're given a 3x3 matrix, capital A, so if A is defined by A11, A12, A13, A21, A22, A23, and A31, A32, A33. So if you have a 3x3 matrix of that type, so then in order to work out the determinant of that matrix, so remember, determinant is denoted by this symbol. So this is how you would write down the determinant of A. Okay, so for the determinant of A, you could expand using rows or columns. Okay, so remember in one of my videos I've said that for 3x3 matrix there are signs associated with rows and columns. Okay, so I'm going to expand using the first row, so I'm going to write down plus, minus and plus. These are the signs associated with the first row of a 3x3 matrix. So if I take that first row, it's plus A11 multiplied by the determinant of a 2x2 matrix, and the elements of that matrix would be found by ignoring the row and column. So let me take 2 pens. So if you ignore the row and the column associated with that element A11, the elements of the 2x2 matrix would be A22, A23, A32, A33. So A22, A23, A32, A33. Okay. Minus A12, so minus A12 multiplied by a 2x2 determinant, and the elements of this 2x2 determinant can be found again by ignoring the row and the column associated with A12. Okay, so if we ignore the row and the column, the elements of this determinant are A21, A23, A31, A33. So A21, A23, A31, A33. And finally plus A13 multiplied by a 2x2 determinant, and if we ignore the row and the column involving A13, the elements of this 2x2 determinant would be A21, A22, A31, A32. So A21, A22, A31, A32. So if we expand further the 2x2 determinants, so remember, to calculate a 2x2 determinant, you multiply the elements along the leading diagonal. So I highlighted the leading diagonal in red, and then subtract, and then multiply the elements along the lateral diagonal or the opposing diagonal. So I highlighted the lateral diagonal in green. So it's going to be A11, open a bracket, multiply the elements along the leading diagonal, A22 times A33, A22, A33, minus, then multiply the elements along the opposing lateral diagonal, A23 times A32, A23, A32. Okay? minus the A12 from here, multiplied by, same approach here, so multiply the elements along the leading diagonal highlighted in red, A21 times A33, A21, A33, minus, and then multiply the elements along the lateral diagonal highlighted in green, A23 times A31, A23, A31. Okay? And finally, so plus A13, open a bracket, multiply the elements along the leading diagonal. So if we do that, A21 times A32, A21, A32, minus, then multiply the elements along the lateral diagonal, A22 times A31, A22, A31. Okay? So here's the procedure for working out the determinant of a 3x3 matrix. You could also relate it to minors and cofactors. So in a previous video I explained the terms minor and cofactor of an element. So you could also say it's plus A11 multiplied by the minor of A11 minus A12 multiplied by the minor of A12 plus A13 multiplied by the minor of A13. And as I explained at the beginning of this video, you could also expand or calculate your determinant using columns also. So you could use any row or any column of your 3x3 matrix and use that respective row or column to calculate its determinant. Okay? So let's try some examples. So example number 1. Let's take a red pen, underline that. So question is, let's find the determinant of the following matrices. Okay, so let me call this part A. So let's find the determinant of this matrix capital A, and it's defined by 1, 2, minus 3, 2, minus 1, minus 1, and 3, 2, 1. So let's calculate the determinant of that matrix A. So I like to expand using the first row, but as I said, you can use any row or any column and follow the same procedure. So if I expand using the first row, signs associated with the first row are plus, minus and plus. So if we expand, it's plus 1 multiplied by the 2x2 determinant, and remember the elements of that determinant would be found by ignoring the row and the column involving that element. So if I ignore the row and column, the elements of this determinant are minus 1, minus 1, 2, 1. Okay, minus 2 multiplied by another 2x2 determinant. So ignore the row and column involving that element 2. And the elements of this determinant are 2, minus 1, 3, 1. Plus a minus 3, so minus 3. Multiplied by the determinant of, so the elements of this determinant are found by ignoring the row and column involving minus 3. So if you ignore the row and the column, the elements of this determinant are 2, minus 1, 3, and 2. So if we continue further, we're going to have 1 multiplied by, so remember, multiply the elements along the red leading diagonal. So if I multiply those elements, minus 1 times 1 minus 1 minus, then multiply the elements along the lateral green diagonal. Minus 1 times 2 is minus 2, with that minus is plus 2. Okay, so just be careful. Minus the 2, open a bracket, same idea here, multiply the elements along the leading diagonal. 2 times 1 is 2, minus, then multiply the elements along the lateral green diagonal. 3 into minus 1 is minus 3, together with this minus is plus 3. So minus 3 into, multiply the elements along the leading diagonal highlighted in red. 2 into 2 is 4, minus, then multiply the elements along the lateral green diagonal. 3 into minus 1 is minus 3, with this minus here, plus 3. Okay, so if we simplify this, minus 1 plus 2 is 1, times 1 is 1, okay? 2 plus 3, 5, 5 times minus 2, minus 10, and 4 plus 3 is 7, 7 times minus 3, minus 21. Okay, so if we simplify further, 1 minus 10 minus 21 is minus 30. So that will be the determinant of the first 3 by 3 matrix. Okay. So here's the method involved to work out the determinant. Okay. So let's try another example. So on the reverse side, let me call this part B. So if we have a matrix B, and if it's defined by 3 minus 4, 2, 1, 5, minus 3, and 5, 3, minus 1. Question is the same. Let's work out its determinant. So let's work out the determinant of that matrix B. So once again, let me expand using the first row. So the signs associated, plus, minus, and plus. So it's plus 3 multiplied by a 2 by 2 determinant. The elements of that determinant, remember, ignore the row and column involving that first element 3, and the elements of this determinant are 5 minus 3, 3 minus 1. Minus of a minus 4 multiplied by another 2 by 2 determinant. So ignore the row and the column involving minus 4, the second element, and the elements of this determinant are 1 minus 3, 5 minus 1, plus 2 multiplied by another 2 by 2 determinant. So if I ignore the row and the column involving that element 2, the elements of this determinant are 1, 5, 5, 3. So 1, 5, 5, 3. Okay. So using the same idea as before, so it's going to be 3, open a bracket, multiply the elements along the leading diagonal highlighted in red. 5 into minus 1 minus 5, minus, then multiply the elements along the opposing diagonal in green. 3 into minus 3 is minus 9, with this minus, plus 9. Okay. Minus into minus 4 is plus 4, open a bracket. Multiply the elements along the leading diagonal. 1 into minus 1 is minus 1, minus, then multiply the elements along the opposing diagonal. 5 into minus 3 is minus 15, with this minus, plus 50. Okay. Finally, plus 2, open a bracket, multiply the elements along the leading diagonal. 1 times 3, 3, minus, Then multiply the elements along the opposing diagonal. 5 into 5, 25. Okay. So if we simplify further, minus 5 plus 9 is 4. 4 times the 3 is 12. Okay. Minus 1 plus 15 is 14. 14 times 4, 56. And 3 minus 25 minus 22 times plus 2 minus 44. Okay. So if you simplify further, 12 plus the 56 minus the 44 should give you 24. So that's the determinant of B. Okay. So here's the method involved in order to work out the determinant of a 3 by 3 matrix. There are other methods also, okay, but here is one of the methods to work out the determinant of a 3 by 3 matrix. And yes, so that ends these examples, and that ends this video also. So I hope you found this video helpful. Do related practice questions, and I hope to see you soon. Thank you.